Welcome to ShiftWatch. I'm your host, Starbuck. In this episode, after a surprisingly popular podcast with the ladies at Ethereal Edge podcast a few weeks ago, here is part 2 of this series I promised to deliver with evidence of multiple light being interactions. Next, Ben from Suspicious Observers shares his perspectives on what influence the sun is having on all the seismic and extreme weather instances going on. Then, here is more evidence of the shift taking place on Earth. The African continent is splitting. And finally, Dr. Tamika Skov brings us an update on the current elevated sunspot activity and a peek at what's on the far side of the sun making its way around to an Earth-facing position.
We hold in our hands the capacity with the technology to capture multidimensional things when you vibrate at that rate. We're going to see evidence of it today. This is a portable time machine, and each one of these pieces is an individual component. The piece that kind of looks like a little Tesla tower is meant to power this. Those are 2 separate pieces, and they fit only one way perfectly. This has to balance in order for any of it to work. But in the event that it does, it's said that you breathe your intent over this and off you go down the timeline you wish to go. Who hands me this red container and said, if you want to know more about your light journey, this is for you. At 1/8 of a teaspoon a day, I will ceremony with this, and my DNA cracked open. Now I'm fascinated. It happened twice. What the hell is this? And then one more time, I hear it coming from now behind my head, and I feel a sensation of energy that just goes. We started to do things and understood enough about atomic energy back in the 40s and the 30s when we turned that into an atomic bomb and showed them what we could do to the planet when we dropped it on Hiroshima. That was the point at which they decided no more hands off. We're not going to allow humans to destroy a cosmic asset. And so we're going to begin to step in. Now, what forms was that going to have to take? They still can't interact in this density. So that's when you heard about the people that Dolores Cannon was writing about. Here's the first wave of beings like that incarnated here so that we could affect a change once we would wake up to understand what our purpose was in this incarnation. And I suspect I'm one of them. Here is where the light baton actually got passed from their realm to this one. And so I carry that code and have had it since, given the parameters of non-interference. But even that veil's been lifted, and things are being shown to us right now that we were unaware of before in preparation for what we're about to go through.
Good morning, folks. We've got a lighter day news-wise. Not like you don't have a ton to take in on other topics today, right? But we'll hit sunspots, earthquakes, and solar storms taking out satellites. We are starting with the last 24 hours on our star, where we see continued M-class solar flares. Massive plasma filaments remain as well, and we've got both north and south coronal holes. There's a lot to keep an eye on in terms of the solar wind this coming weekend and the filament eruptions, but I'm firmly focused most significantly on the leading incoming sunspots. We have some bigger spots departing to the right, but they are less complex. The incoming ones on the left, nearer to the equator, are very complex, and most of all this morning it would be the leading group, the one out ahead. This one is not only more closely packed in, but the sunspot umbra are a bit bigger, and if we look at the sunspot magnetism, we can see several areas with interaction potential where positive and negative polarity are ready to collide. That is how you get solar flares. Now, in addition to all the sunspots and filaments and coronal holes, the 171 angstrom view indicates more is coming right behind the equatorial sunspots. That is a very bright signature over there at the limb coming in. Quick seismic note here. The quakes on the west coast of South America are all blot echoes. This is one of the several signs we look for when seismic activity is about to amplify in an area. Hopefully, the surface realizations of that deeper pressure are not too big. Up next, we've got the first story about solar storms and satellites. One of the Starlinks was ready to descend and burn up. Its life was over. But this one came in way earlier than it was supposed to. They blame the puff-up of plasma during the solar storm degrading the orbit ahead of schedule, but that really can't be blamed for what's going on with the joint polar satellite. U.S. sources indicate that it has begun losing control and may not be recoverable. And for this one, we're looking at the 5-day proton storm we just had. The internal charging surged during the peak of the storm on Halloween, and 2 days later when the satellite began to break, we were still in those storm conditions. Unusual and more than we expected to see here in this event.
Welcome to the incredible story of how Africa is literally breaking apart right before our eyes. In a geological event that sounds like it's straight out of a sci-fi movie, the African continent is slowly but surely splitting into two. This isn't the work of fictional prehistoric squirrels or movie magic. It's a real, ongoing process that's reshaping our planet's geography. Today we're diving into this fascinating phenomenon. Stay tuned to learn all about how Africa is splitting into two continents. Africa's tectonic drama. To comprehend the incredible phenomenon of Africa potentially splitting in two, we must first set the stage by understanding the basics of plate tectonics. Our planet's outer layer, the lithosphere, is composed of several large plates that float atop the semi-fluid mantle beneath. These plates are in constant, albeit slow, motion, moving at speeds comparable to the growth of your fingernails. The African continent, long thought to sit atop a single tectonic plate, is now understood to be undergoing a dramatic change. Evidence suggests that this massive landmass is slowly breaking apart along what geologists call the East African Rift System, EARS. This rift is essentially a crack in the Earth's crust that extends over 3,500 kilometers, 2,174 miles, from the Red Sea in the north to Mozambique in the southeast. The East African Rift. The East African Rift is not just any ordinary crack in the ground, it's a complex system of rifts, faults, and volcanic activity that's been shaping the African landscape for millions of years. This rift system is responsible for creating some of Africa's most iconic geographical features, including the towering peaks of Mount Kilimanjaro and Mount Kenya. The rift began forming approximately 25 million years ago, but its effects are still very much ongoing. It's along this rift that scientists believe Africa is slowly splitting into two separate plates, the Nubian plate to the west and the Somali plate to the east. This geological process is not just of academic interest. It has profound implications for the future of the continent, potentially reshaping its geography, climate, and even political boundaries over millions of years. The Kenyan Crack. In March 2018, the world received a stark reminder of the ongoing tectonic activity in East Africa. An enormous crack suddenly appeared in southwestern Kenya, stretching for several kilometers and even swallowing a section of the Nairobi-Narok Highway. This dramatic event reignited public interest and scientific debate about the future of the African continent. While initial reports linked this crack directly to the continental split, further investigation revealed a more nuanced story. Geologists now believe that this particular fissure was likely a pre-existing crevice filled with volcanic ash from past eruptions. Heavy rains caused the waterlogged ash to collapse, exposing the crack. However, even though this specific event wasn't a direct result of continental rifting, it served as a powerful reminder of the dynamic geological processes at work beneath our feet. Mechanics of continental breakup. So, how exactly does a continent split in two? The process begins deep within the Earth, in the hot, semi-fluid mantle that lies beneath the rigid tectonic plates. Current theories suggest that plumes of heat rising from the mantle are causing the lithosphere beneath Kenya and Ethiopia to dome and stretch. As the lithosphere thins, it becomes more susceptible to cracking. This has led to the formation of numerous faults and fissures along the East African Rift. From above, these features appear as deep crevices and elongated basins, separated by regions of higher elevation. The process is also accompanied by significant volcanic activity. Large-scale eruptions, known as flood basalts, have occurred along the rift, with lava gushing from emerging fissures like floodwaters. This volcanic activity not only shapes the landscape, but also provides further evidence of the thinning lithosphere and the upwelling of material from the mantle. Measuring the split. One of the most fascinating aspects of this continental breakup is that we can actually measure its progress. Using GPS technology, scientists have been able to track the movement of the Nubian and Somali plates with remarkable precision. Current measurements indicate that these plates are diverging at an average rate of about 7 millimeters, 0.2 inches per year. While this might seem slow by human standards, it's actually quite rapid in geological terms. Over millions of years, this steady movement can result in dramatic changes to the landscape. To put this in perspective, if we could fast forward millions of years into the future, we might see a very different African continent. The rift could widen significantly, potentially allowing oceanic waters to flood in and creating a new sea separating East Africa from the rest of the continent. The future African landscape. As we peer into the geological future, the potential changes to Africa's geography are both exciting and profound. If the rifting process continues as it has been, we could see the emergence of a new ocean basin in what is now Eastern Africa. Countries that are currently landlocked, such as Uganda and Ethiopia, might find themselves with new coastlines. This could have significant implications for trade, economics, and geopolitics in the region. New maritime routes could open up, potentially transforming these nations into important ports of call. Moreover, the creation of a new ocean would dramatically alter the climate and ecology of the region. Areas that are currently arid could become more humid, potentially leading to changes in vegetation and wildlife distributions. However, it's important to note that these changes won't happen overnight. The complete separation of East Africa from the rest of the continent, if it occurs, is estimated to take anywhere from 5 to 10 million years. So while we can observe and measure the process, none of us will be around to see its final outcome.
Space weather this week is really picking up in activity. As we take a look at our Earth-facing disk, there are a lot of regions in Earth view, and we've been following the big flare players. In fact, region 3869 is finally rotating to the sun's west limb after giving us a bit of big flare activity over this past week. We also have region 3878, which continues to give us some big flares, but the one that's taken center stage is region 3883. Watch it, pow, right there. It fires off a near M4 class flare along with a big solar storm. In fact, as we take a look at it in stereo coronagraphs, you can watch this very dense structure move off to the northeast. And it looks pretty much like this one's going to miss Earth. However, when we follow it in and look at the blast wave more carefully, whoosh, you can see that big blast wave going off like that. And you can actually see some of the dimming regions are actually in the Earth strike zone. So this particular solar storm might actually have an Earth-directed component. So we're going to be paying close attention to region 3884 as it continues to rotate in through the Earth strike zone, because this region is still firing big solar flares and it could have more Earth-directed solar storms. And now as we switch to our sun's far side, we no longer have any spacecraft that are looking at the sun's far side, at least not for the moment. So we need to switch to simulated far side using AIA and HMI imagery of about 2 weeks ago to see what kind of sunspots might be lurking there. And as we take a look, we can see regions 3859, 3860, and 3857. These are the regions that have been rotating into Earth view on the east limb. In fact, I think region 3859 is likely new region 3883. But as we take a look at our JSOC HMI helioseismology far-sighted viewer, you can see region 3860 as it rotated to the sun's far side back on the 25th, and it continues to grow. So this whole set of regions, you can even see a little bit of activity here as well. These regions are going to be rotating into Earth view here over the next 3 or 4 days, and so that does mean we're going to have some more activity. We've got a few big flare regions that could give us more, keep that solar flux high and keep big flares on the menu, but then we've got a break. Do you notice this? We've got about a break of probably 3 or 4 days where things might begin to quiet down. So if we can kind of get through the mess that we've got right here, then we might settle down in about 7 to 10 days for a bit of a break before things get really crazy with all those older regions that rotate back into Earth view, with region 3869 leading the charge. And now, returning to that solar storm that could be on its way to Earth, we take a look at our solar storm prediction model, Lowell. Now, this is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the sun from the North Pole, with Earth being off to the right. And as I set this solar storm model in motion, you'll see that storm being launched pretty much to the east of Earth. But it does look like just the tail end of this structure does hit Earth right about late on the 6th, early into the 7th. NOAA's expecting it to be about 2 o'clock UTC time on the 7th. So aurora photographers, if you're at high latitudes, you could probably get a little bit of a show. But if we switch to the NASA version of the model, again, you're looking down at the sun from the North Pole, with Earth being off to the right. As I set this model in motion, you can see again that solar storm being launched, but this time it looks like it's moving a little bit more quickly. In fact, NASA has this storm hitting us about midday on the 6th. And so if the storm hits on the 6th, then it could be a little bit more intense of a blow, which could give us a bit more of an aurora show. But somewhere in that window between about midday on the 6th and early into the 7th, we could expect to see just a little bit, but I'm only expecting aurora photographers at high latitudes to get a decent show from this. Aurora photographers at mid latitudes, stay on your toes, but likely you're going to need to sit this one out.